Good morning, my YouTube viewers. It is Crystal here. I haven't made a video in a few days or several days because I've been studying, and so what I'm doing today is I'm doing a code review on what it is I've been studying. And so basically I've been studying this library called Jax, which I never even heard of until about a week or so ago. And Jax is a library that's written by Google Brain, and with Google Brain, it's written on the back of NumPy, so it's similar to NumPy, but it's a lot faster and a lot more powerful. And so basically what I wanted to do is I wanted to do linear regression in Jax. So I found lots of sample code or code for linear regression on the internet. But the code that I found for linear regression on the internet was when people created synthetic data sets either by using NumPy or by using sklearn's make regression module. But whenever I tried to use the same model to make linear regression on an off-the-shelf data set, it wouldn't work. And so what I had to do eventually was I just had to take a linear regression made with NumPy and convert NumPy to Jax, because Jax is sort of like a wrapper for NumPy, and Jax is sort of written on top of NumPy, and Jax is very similar to NumPy, only it's faster and more powerful and does a lot more things. So that's what we're going to do in this particular code review. We're taking a linear regression module made on NumPy, and we're going to convert that to Jax. And the reason why I have to do this is because all of the linear regression models for Jax, although they were a lot more complicated, just didn't work whenever you took a data set off the shelf and used it. So, I'm still going to have to find more data sets and more code on Jax to use to try to solve this problem. One thing that I've learned in my studies is that Jax is going to be replacing TensorFlow for research purposes anyway, because TensorFlow has keras, and a lot of people like using keras because it's not as hard to use as the hard coding of TensorFlow or coding by scratch. So that's why I wanted to learn to use Jax, since it's going to be replacing TensorFlow. But I think it will replace TensorFlow for researchers. But keras is a very good library, and I use keras on my TensorFlow work as well. So for people who are doing machine learning, I don't know, I think they're going to want to stick with keras, but you never know, they might want to go to TensorFlow. So what we'll do is we'll go ahead and start on the code review. First thing we're going to do is we're going to import our libraries. So we're going to import random to make random numbers. We're going to import NumPy as NP. That's to create your NumPy arrays and perform linear algebra and perform other numeric computations. We're going to import Jax. Somewhere down the line, we're also going to import jax.numpy as JNP. And we're going to import CSV. So what we're going to do is, instead of using pandas to read the CSV file, which is what we normally do, we're going to use Python's inbuilt CSV module to read the CSV file. So we're going to create a function called load dataset. So def load dataset file name with open file name R means you're reading it as CSV file, lines equals CSV.reader CSV file, dataset equals list lines, headers equals dataset 0, dataset equals dataset 1 to the end of the dataset, and then it's going to return the dataset and the headers. And then so this is what we're going to do, because when you develop functions, you do the function first and then you do the code after you do the function. So dataset headers equals load dataset, and then I've got a house price dataset that I saved onto my Google Drive. I tried to get it to work on GitHub, but it wouldn't work on GitHub, or I couldn't get it to work on GitHub. So I had to save it into my Google Drive and then call it up that way. We're going to print the headers, and you see you've got like number 1, then you've got price, square foot, bedroom, bathrooms, offers, brick, and neighborhood. We're going to print the data set, so you can see that each row of data is an array. So what we have is we have a list of arrays. Then we're going to print the dataset size. So you're going to print the length of the dataset, which is the length of the header, so dataset 0. So I don't know why they said len dataset 0, but dataset 0 is headers. So you could just as easily have said print len dataset times len headers, but that's the way it was done. So you got 128 rows by 8 columns of data. So now what we're going to do is we're going to manipulate the dataset. So dataset equals NP array dataset, X equals dataset, all of the rows by columns 1 to 4. And then the type of the dataset is going to be float. And then we're going to define the Y variable. So Y equals dataset, all of the rows by 1, and Y equals as type float. So we're going to get the size of X and the size of Y. So X is 128 by 4, and Y is 128. So now we're going to add 1s to X. 1 equals np.1s, len X 1. X equals np.append 1, X axis equals 1. And then reshape Y to a column vector. So Y equals npy.reshape len Y 1. So you print X and then you print Y. So X is 128 by 5 and Y is 128 by 1. Now, so we're going to print X head, and then you're going to display X 0 to 5, and then you're going to print Y head, and you're going to display Y 0 to 5. And so you can see the first 6 columns, I believe, or the first 5 columns of X and Y. Now I decided to put it in here to set the seed. So np.random.seed42, jax.random.prngk42. So we've set the seed in both random and Jax. I wanted to suppress the scientific notation. So np.set print options, precision equals 2, suppress equals true. And I don't think it really suppressed it. I wonder if you're supposed to say in place equals true, but anyway, I don't think it really suppressed it. I could try in place equals true and see what happens. And then I tried to standardize the data, but it didn't work as well when I standardized the data, so I didn't. And quite often you don't have to standardize the data in linear regression, but you should give it a try. Try it with standardization and then try it without standardization and see which one works best. And the same goes with normalization. So now we're going to split the data set into training and testing sites. So we're going to create a function for that. So def train test split, xy split, indices equals np.array range len x, train size equals round, split times len x, random.shuffle indices, train indices equals indices 0 to train size, test indices equals indices train size to len x. X train equals X train indices, all of the columns. X test equals test indices, all of the columns. Y train equals Y train indices, all of the columns. And X test equals, Y test equals Y test indices, all of the columns. And then it returns X train, Y train, X test, Y test. And then so you've got, we're going to use the train test split function. Split equals 0.7. X train, Y train, X test, Y test equals train test split, X, Y split. And then you get the shape of 90. X train is 90 rows by 5 columns. Y train is 90 rows by 1 column. X test is 38 rows by 5 columns. Y test is 38 rows by 1 column. Okay, so now what we're going to do is we're going to print the shapes of all of this, which we don't really need to do because I've done that previously. So I can just delete that really. Since I've already done that, I've already done my shapes. So now we're going to check the item size. So, the item size is X train, print X train item size, and Y train item size, X test item size, Y test item size. And so all of the item sizes are going to be 8. And you want to make sure that the item size of each variable is the same, otherwise it won't work. And I'm sure that when I was trying to get the program to work, I had an error about the item size, which is why I included item size in this code. Now what we're going to do is we're going to define the Jax model. And Jax is very similar to the NumPy API, and because of that, and because I had so many problems getting a good linear regression model, I just took a NumPy model and I converted it to Jax. So you import jax.numpy as JNP. So def normal equation xy beta equals jnp.dot. So by jnp.lenout.inverse over jnp.dot x transform x, jnp.dot x transform y, and then it returns the beta. And then when you want to predict on it, we created another function called predict. So def predict x test beta, return jnp x test x jnp.dot x test dot beta. And then the dot function is the dot product. So now that we've created our 2 functions, beta equals normal equation, x train, y train, and predictions, and so that gives you your beta. And then predictions equals predictions, x test beta, and then so we get our predictions. And so we're going to calculate the mean squared error. When we calculate the mean squared error, we got a 0.62, which isn't too bad. And then we're going to plot it on a graph, and you can see the predictions are plotted against the actual values. So that looks pretty good. And now what we're going to do is we're going to compare sklearn to this Jax linear regression model. So from sklearn.linear model input linear regression, regr equals linear regression dot fit x train, y train, and then you print the score, which is 1. And then ypred equals regr dot predict x test, and so you print the score, which is 1. And now what we're going to do is we're going to check the RMSE of y test and ypred, and your RMSE is 0. So that's very good as well. And then we print our predictions against our actual values, and you can see the predictions against the actual values are very good as well. So the thing is that sklearn's linear regression worked a little bit better than our Jax linear regression. So that's interesting. But that I just wanted to do a comparison between Jax and sklearn just to make sure that I was getting the model correct. And you can see that I was getting the model correct, but sklearn worked a little bit better. I don't have the sample code for sklearn's linear regression, so if I had the sample code, I would try to convert it to Jax, but I don't have it. So I'm going to go ahead and conclude this code review because we covered all of the topics that we wanted to cover. I'd like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And if you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more code reviews for you in the future.